Let's take a look at this globe to try to understand the Coriolis effect. Coriolis effect is something we refer to, well, kind of hard to explain in just words, so let me try to explain it with this globe here. If you have a lot of hot air around here, this is the equator, you'll naturally have a lot of hot air around the equator. So you know what happens to hot air. Hot air rises. And since hot air rises, low pressure forms underneath hot air. Now you probably remember what happens when you have low pressure. Wind tends to flow from high pressure to low pressure. So what's going to happen around the equator here, and probably way more than around the equator here, you're going to have all this low pressure. And since wind wants to blow from high pressure to low, well, where in the world would you have a lot of high pressure? Well, think about this. You have a lot of heat where there's low pressure. Where would you have a lot of cold? Well, it's going to be the North and the South Pole. Here we have the Arctic Circle, North Pole above that. Let's get rid of that. And the Antarctic Circle, South Pole below that. So you're not going to have much low pressure here. You're going to have high pressure here. So since wind wants to blow from high pressure to low, generally you have a lot of wind that wants to go from the North Pole to the equator and from the South Pole to the equator. But there's a problem with that. The problem is you have the Earth that is spinning. It has that rotation that happens every single day. Every single day the Earth will spin one complete time. So if you have wind that has started out here anywhere near the North Pole and starts going toward the equator, literally it's going to curve. It's not going to be able to take a straight line. It's just not. And the reason, well, we use the term Coriolis effect for the effect of things in the atmosphere when the Earth underneath it is turning. Now we've got a lot of things in the atmosphere, more than just air. You have the water as well. Well, I say a lot of things. You have the water as well as the air, and anything that you put in the air, like airplanes. But anyway, let's see what that does to the Earth's winds. Instead of having the Earth's winds go straight down toward the equator like they want to, the Earth's winds have an actual curve to it. And you can see what happens here. The path that would take without the Coriolis effect is here, and the path that it actually takes is there. So as a result, you're going to have some interesting wind patterns that don't always look like this arrow. Here's what we have. We have all these winds from the North Pole that start blowing toward the equator, and they are quickly changed, pointing out to the west. And you can see you have that all throughout the North Pole area, and way down here at the South Pole area, same exact things happening. It starts blowing in and it goes off to the west, which is kind of odd because these are called the easterlies. Now, whenever these were made up, the easterlies is the direction it comes from, not the direction it blows toward, because the easterlies blow toward the west. But what happens here, you have this pattern here, and it doesn't get very far. So since you have the globe turning, and since you have the pressure as it is, we tend to have a global wind pattern underneath that called the westerlies, where the wind blows up and to the west. You know, I said that wrong. It's up and from the west, blowing to the east. Now, where we live here in Georgia of the United States, you can just like barely even see it over here, but you can see from the fact where my dot is, most of our wind patterns and our weather patterns come from the west and blow to the east because they get caught up in these westerlies. Now you have some westerlies which are down in the southern hemisphere, and they are blowing in the same direction. All the winds that are titled the same thing are blowing in the same directions. Westerlies all blow that way, which is to the east. Ironically, easterlies always blow to the west. And notice you have another group of winds here. They're called the trade winds. Now you see you have northeast trade winds and southeast trade winds. You just know that they're trade winds and northern and southern hemisphere. So the trade winds are farther south. Now think about this. We have Florida, which is probably about right here. So these are trade winds. These trade winds don't necessarily affect us as much outside of, well, hurricane season, which I'll talk about in a moment. But anyway, these trade winds will blow to the west. They will blow to the west. And actually the reason they're called trade winds is you would have like ships that would set sail, like say here in Africa, and once they set sail, they get caught up in these winds, and they really push the ship at a very rapid pace over to like South America here, where they could trade, and have business. So that's why they were called the trade winds. And you have these trade winds down at the south here, which do the same exact thing in the southern hemisphere. Now, something you may have noticed is we have something called the doldrums. With the way you have these three wind patterns, the easterlies, westerlies, and north trade winds, or trade winds, you're going to have these areas where you don't have quite as much wind. Here between the trade winds is this area right along the equator. This area right along the equator is called the doldrums. Now, the doldrums is an area where you just don't have much wind. And there have been reports of ships that accidentally get caught out in the doldrums, and they just sit there. They just sit there unless they have some kind of steam power or gasoline power or something like that, because if it's wind power, you're not going to get much down here in the doldrums for the most part. You have another common area right here called the horse latitudes. Now, I know why they call things the trade winds, but I don't have a clue why they started calling these the horse latitudes. But for whatever reason they called it that, this is also an area like the doldrums where you just don't get that much wind. Now, down here in southern Florida, you kind of get toward a little of those horse latitudes. So that's one reason why Florida sometimes has nice, peaceful weather patterns. Not always, of course, because Florida does get a lot of rain, but it's kind of creeping more toward this horse latitude, Caribbean Sea type area. Well, anyway, I'd like for you to be able to identify the easterlies, westerlies, trade winds, where you would find the horse latitudes and the doldrums, and why you have those. And it's because of the pressure and the Coriolis effect. Now, the Coriolis effect also affects hurricanes. Now, the spin of a hurricane is going to be this direction if it is in the northern hemisphere. In the southern hemisphere, it's not going to spin in this direction. It's going to spin in the opposite direction. And it's because of the Coriolis effect. The Coriolis effect, the effect of the air and the wind that is on top of a spinning earth. And because of the spinning earth, it's going to spin the hurricanes that direction. And it's not only hurricanes that are spun in that direction. You have something I didn't know until I started researching this, is pinwheels. Now they said pine wheel, don't know why they said pine wheel. But if you have a pinwheel, south of the equator will spin in clockwise direction, and a pinwheel north of the equator spins in a counterclockwise direction, which I think is the same direction as the hurricanes. There are other things that spin in that direction, like water in sinks and toilets. As you probably noticed, there is a definite direction that the water spins. Hey, that's the same direction that hurricanes spin. That's the same directions that pinwheels spin. And it's going to be true with any body of water, howbeit small body of water, that is flushed down a drain or flushed down a toilet or goes down the drain.